Good morning, everyone. Welcome to Annamacharya University. I am K. Adhisekhar Babu, Assistant Professor in the Department of MCA at Annamacharya University. I will be teaching Mathematically Foundations of Computer Science. Now, in this video, we will discuss about mathematical foundations of computer science in recurrence relations. What is meant by recurrence relation? A recurrence relation is a rule or formula that defines each term of a sequence using one or more of the previous terms in that sequence. That is a n term and n minus 1 term, that is n and n minus 2 term. In the recurrence relation, mainly in that recurrence relation, previous terms of that sequence, that is nth term, n minus 1 term, n minus 2 term, n minus 2 term. Recurrence relation means nth term, n minus 2 term, and n minus 2, and so on. Mainly previous terms of the recurrence relation. Now we will discuss the second order homogeneous recurrence relation. Second order homogeneous recurrence relation. That means suppose n and k are non-negative integers. A relation of the form c naught n into an plus c1 n into an minus 1 plus c2 n into an minus 2 and so on, ck n into an minus k equal to f of n. That is equation number 1 for n greater than or equal to k. This is a recurrence relation. Where c naught of n, c1 of n, c2 of n, and so on, cn of k and f of n are functions of n. Here c naught n, c1 n, c2 n, and so on, cn of k, even cn of k and f of n are the functions of n or constants, is said to be a linear recurrence relation. If f of n equal to 0, here in the given recurrence relation f of n equal to 0 in equation 1, f of n equal to 0 in equation 1, then the relation is said to be homogeneous linear recurrence relation. Equal to 0 means homogeneous linear recurrence relation with order k. For example, an minus 2an minus 1 plus 5an minus 2 equal to 0. This is a f of n equal to 0. This is a homogeneous linear recurrence relation. F of n not equal to 0 means non-homogeneous recurrence relation. Now we will discuss order of a recurrence relation. How to find a order of a recurrence relation? The order of a recurrence relation is the difference between largest and smallest subscript appearing in the relation. Mainly largest and smallest subscript appear in the relation to find a order. For example, an plus 3an minus 1 equal to 0. This is a homogeneous recurrence relation. Here, how to find the order of a given recurrence relation? That is order equal to highest subscript. That means largest subscript and smallest subscript. Difference between the largest and smallest subscript equal to order. Here in this example, n is the largest subscript and n minus 1 is the smallest subscript. Order equal to difference between largest and smallest subscript in the given recurrence relation. Order equal to n minus of n minus 1, that is equal to n minus n plus 1. Here n cancel, that one n equal, order equal to 1. And another example, an plus 3an minus 1 plus 2an minus 2 equal to 0. Order equal to, here highest subscript is n, smallest subscript is n minus 2. In this given recurrence relation, the order is 2. That is n minus of n minus 2 equal to n minus n plus 2, n minus n 0 plus 2 equal to 0 plus 2 equal to 2. Here that is the order of any recurrence relation. by solving the recurrence relation by using the characteristic roots method. Now we will discuss characteristic roots method. Here, let an plus c1 an minus 1 plus c2 an minus 2, that is, and so on, ck an minus k equal to f of n. Here, order is n greater than or equal to k. Last subscript is n minus k, n greater than or equal to k. If f of n equal to 0, then the recurrence relation is said to be homogeneous. F of n equal to 0 means that is homogeneous linear recurrence relation. Therefore, the general solution of any recurrence relation is an equal to an of h. Homogeneous f of n equal to 0 means that is homogeneous. Any homogeneous recurrence relation, the general solution is an equal to an of h. To find how to find an of h. To find an of h, first step 1 is write the characteristic equation of the given recurrence relation. First thing is write the characteristic equation to the given recurrence relation, that is t power k plus c1 t power k minus 1 plus c2 t power k minus 2 and so on, ck equal to 0. Now we find the quadratic equation, like quadratic or cubic equation, that is the characteristic equation in homogeneous recurrence relation method. Second step, find the roots. Find the roots of the given recurrence relation by using characteristic equation. Characteristic equation based on the nature of the roots. Based on the nature of the roots, an of h is as follows. To find, based on the roots, you find the an of h. General solution of an of h. n equal to c1 plus c2n plus c2n square plus and so on, ck power n power k plus 1 into alpha power n is the general solution of roots are equal. Last case is roots are complex. If alpha 1 comma alpha 2 are complex, then n equal to r power n into c1 cos n theta plus c2 sin n theta. Here r equal to mod a plus or minus ib, that is equal to r equal to square root of a square plus b square. And how to find theta? Theta equal to tan inverse b by a. Now we will discuss one example problem in a homogeneous linear recurrence relation with order 2. Problem is solve the recurrence relation an minus 7an minus 1 plus 10an minus 2 equal to 0. This is a homogeneous or non-homogeneous? Equal to 0 means that is homogeneous linear recurrence relation. Here f of n equal to 0. That means this is a linear homogeneous recurrence relation with n greater than or equal to 2 and initial conditions a0 equal to 10, a1 equal to 41. Now by using characteristic roots method to solve this problem. First one, given recurrence, that is an minus 7an minus 1 plus 10an minus 2 equal to 0. Equation number 1. a0 equal to 10, a1 equal to 41. By using characteristic roots method, the characteristic roots method is the characteristic equation of given recurrence relation is here order is 2. Highest subscript means here highest subscript is n and smallest subscript is n minus 2. The difference between largest and smallest subscript equal to is called order. Here highest subscript is n, highest subscript is n and smallest subscript is n minus 2. The difference between largest and smallest subscript is called order. That is n minus of n minus 2 equal to 2. Here order is 2. The given equation is a second order homogeneous linear recurrence relation with initial conditions a naught equal to 10, a1 equal to 41. Now, by using characteristic roots method, now the characteristic equation is t square minus order is 2. The quadratic equation also starts from 2. T square minus 70 plus 10 equal to 0. Here t square, first term is t square, second term with constant, one constant also there, that is minus 70. Last one is only constant term. First term is t square, second term is t term, last term is constant term. In a quadratic equation, x square term, x term and constant term. Here order is 2, that means t square minus 70 plus 10 equal to 0. Now we find the roots of a given characteristic equation. Here to find the roots by using two methods are there. First method is minus 70 plus 10. Here minus 70 compare with two elements, that is plus 10 and minus 70. What are the multiples or multiples of minus 70 plus 10? That is minus 2t minus 5t means minus 2t. We get minus 2t minus 5t. We get minus 2t. Minus 2t minus 5t means we get minus 70. And minus 5 into minus 2 we get 10. That is equal to t square minus 2t minus 5t plus 10 equal to 0. T of here common with 1t, t of t minus 2, here common minus 5, also same t minus 2 equal to 0. T minus 2, t minus 5 equal to 0. Finally, t equal to 2 or t equal to 5 or t equal to 5 or t equal to 2. To find the roots by using another method also from the characteristic equation, here a equal to 1, b equal to minus 7 and c equal to 10. The formula of the to find the roots is minus b plus or minus square root of b square minus 4ac by 2a. This is a formula of to find the roots. By using this formula also to find the roots. Here minus b means minus 7, minus of minus 7 plus or minus square root of b square means minus 7 whole square minus 4 into a means 1, c means 10, that is minus 4 into 1 into 10 by 2a. Here a equal to 1, 2 into 1. Minus minus plus 7 plus or minus b square minus 4ac kada, that means b square minus 4ac, that means b square means 7 square equal to 49 minus 4 into 10 equal to 40. 49 minus 40 by 2 into 1, 2. That is equal to 7 plus or minus 49 minus 40 root 9 by 2. Root 9 equal to 3. That is equal to 7 plus or minus 3 by 2. 7 plus or minus 3 by 2. Here t equal to 7 plus 3 by 2, that is equal to 10 by 2, t equal to 5, or 7 minus 3 by 2 equal to 4 by 7 minus 3 equal to 4 by 2, 4 by 2 equal to 2. Here roots are t equal to 5 comma 2 or t equal to 2 comma 5. By using any method, in both methods, using any method to solve the roots. Here the two roots are same or real and distinct. Two roots not equal here. Two roots are real and distinct. Here the two roots real and distinct. Therefore, the general solution of a linear recurrence relation is an equal to c1 alpha 1 power n plus c2 alpha 2 power n. Therefore, the general solution is n equal to one root is 5 and another root is 2. Here only two roots. That means c1 2 power n plus c2 5 power n. Therefore, the general solution is n equal to c1 2 power n plus c2 5 power n. This is equation number 2. Here in the question, a not equal to 10 and a1 equal to 41 initial conditions also there. Now we solve the c1 and c2. How to find the c1 and c2 values? By using the substitution method. First of all, a naught equal to which value? A naught equal to 10. A naught equal to 10, substitute in equation number 2. That means here an, here an. How is it? How do you get 0? Put n equal to 0, we will get a naught. That means put n equal to 0 in equation 2. A naught equal to c1 2 power 0 plus c2 5 power 0. 2 power 0 equal to 1. 5 power 0 equal to 1. Okay na? A naught equal to c1 plus c2. That is c1 plus c2 equal to a naught. Here a naught equal to 10. Substitute a naught equal to 10. C1 plus C2 equal to 10. This is equation number 3. Next, A1 equal to 41 na. Put n equal to 1 in equation 2. We get A1 equal to C1 2 power 1 plus C2 5 power 1. That is 2C1 plus 5C2 equal to A1. 2C1 plus 5C2 equal to 41. A1 here A1 equal to 41. 2C1 plus 5C2 equal to 41. Now by solving 3 and 4 equations, we get C1 and C2 values. Here C1 plus C2 equal to 10 is one equation. 2C1 plus 5C2 equal to 41 is another equation. By using 3 and 4 equations, we get C1 and C2 values. Here in the third equation, C1 plus C2 equal to 10. C1 plus C2 equal to 10 and another equation 2C1 plus 5C2 equal to 41. How to solve these two equations? How to get C1 and C2 values? By using the solving method. That is third equation here only C1 and C2. In fourth equation 2C1 plus 5C2. By using multiplication in fourth equation and with 2 or with 5. That is your choice. Here 3 into equation 3 into 2 equal to 2C1 plus 2C2 equal to 20. Here 10 into 2 20. 2C1 2 into C1 2C1 plus 2 into C2 2C2. That is 3 into 2. 2C1 plus 2C2 equal to 20. And another equation is 2C1 plus 5C2 equal to 41. By solving these two equations now, here both are positive, get minus, and also same. Both are same signs, we will change the minus sign. Here also same. That is minus plus 2C1 minus 2C1 cancel. 2C1 2C1 0 plus 2C2 plus 5C2. 2C2 minus 5C2. We get minus 3C2. And 20 minus 41 equal to minus 21. Here minus minus cancel. 3 ones 3 sevens. C2 equal to 7. C2 equal to 7. Substitute C2 equal to 7 in equation number 3. C1 plus C2 equal to 10. This is the equation number 3. C1 plus 7 equal to 10. C1 plus 7 equal to 10. C1 equal to 3. Finally, substitute C1 and C2 values in general solution. Therefore, the general solution of linear homogeneous linear recurrence relation is n equal to 3 into 2 power n plus 7 into 5 power n. Here this is the general solution of the given homogeneous recurrence relation. That is n equal to 3 into 2 power n plus 7 into 5 power n. Okay, thank you so much.